Construction and operation of electrical test and measuring instruments. Ammeter. Explain construction and operation principle of analog and digital instruments for basic electrical quantities measurements, as voltage, current, frequency, power, time and phase displacement. DC voltmeters and ammeters. Whereas voltmeters measure voltage, ammeters measure current. Some of the meters in automobile dashboards, digital cameras, cell phones, and tuner amplifiers are actually voltmeters or ammeters. The internal construction of the simplest of these meters, and how they are connected to the system they monitor, give further insight into applications of series and parallel connections. Ammeter. An ammeter is a device used to measure the amount of current in an electric circuit. The device can measure both alternating current as well as direct current. The device measures the current in the units of ampere. Ammeters are calibrated and modified galvanometers, since like the galvanometers they too measure the current by deflections of the magnetic coil. The ammeter is represented by the symbol. An ammeter is connected series in a circuit. An ammeter is used to detect how much current is flowing through the circuit, so the resistance of the ammeter is very low. By connecting it parallel to a circuit, and this may cause short circuit and burn the ammeter or the circuit. An ammeter is constructed using different parts as shown in the image above. The general construction of an ammeter includes U-shaped magnet. The magnet serves as a major component in an ammeter. It consists of concave poles. Copper coil. The copper coil is generally rectangular and is wound around a metallic core. Iron core. The copper coil is wound around a soft iron core. Due to the presence of the soft iron cylindrical core, the magnetic field between the poles increases and the field lines remain parallel. Pointer. The pointer which is attached to the coil in a pivoting manner to read the deflection. Working of ammeter. When an ammeter is connected in series in a circuit, the current flowing through the ammeter is equal to the current flowing through the circuit. Due to this current, there are deflections in the magnetic coils of the ammeter which moves the pointer across the graduated scale. This results in the measurement of the load current. Types of ammeter. The different types of ammeter are as follows. Permanent magnet moving coil ammeter. The ammeter coil is kept in between poles of a permanent magnet. Depending upon the magnitude of the current, the deflection of the coil occurs, which is translated into the movement of the pointer on the calibrated scale. It is used for measuring DC. Moving iron ammeter. These types of ammeters are used for measuring AC as well as DC. It consists of two small pieces of soft iron. One of them is attached to the coil and the other is attached to the pointer. When the soft iron attached to the coil becomes magnetized, it causes either attraction or repulsion of the other piece of soft iron, which then rotates proportionally. Electrodynamometer type ammeter. These types of ammeters are very accurate and are used to measure both AC and DC. Unlike other types, it consists of two coils and is transfer type equipment. Rectifier type ammeter. This type of ammeter is used to find only alternating current magnitude in the circuit. These types of ammeters use diodes in rectifier arrangement along with a magnetic coil.